All right, so let me give you the end result here. And this is the formula that you're going to use when you do your homework. All right, so if you want to model a function with a Taylor polynomial of the degree n near x equals a, then the formula is you just take f of a, of course, because you want the functions to match at a, and then add the derivative. Oops, that's supposed to be plus. F prime at a times x minus a, all right, and then plus the second derivative at a over 2 factorial times x minus a squared, and then add, gosh, f prime, the third derivative at a over 3 factorial. What? What is happening? Okay. X minus a cubed, and then cubed plus dot dot dot, and then the nth term is the nth derivative. I'm just going to write it like this, of a over n factorial times x minus a to the n. All right. All right, looks like I got everything. Make sure I didn't lose anything along the way. All right, so that's the formula that we're going to use. And so this next example is actually a different function. We're not dealing with e to the x anymore. We're dealing with the natural log. So let's see if we can use this formula to model the natural log near x equals 1. All right, well, first of all, we need f of 1, right? We just need to put 1 into the natural log function and we get 0, right? So we know f of 1 is 0. And then we'll just go through all of the derivatives, okay? So the first derivative of the natural log function is equal to 1 over x. Or I can write that as x to the minus 1, which will come in handy because it's much easier to take the derivative of a power function. So let's write it as a power function. All right, so we want the first derivatives to match at x equals 1. And so we know that the first derivative at 1 is equal to 1. So now we can use the formula to find the first degree Taylor polynomial. Okay, now they don't actually ask for the first degree Taylor polynomial, but we'll just do it anyway. That's because we want to. All right, so f of 1 is 0, right? That's a is 1, right? So we're just going to substitute 1 for a. So f of 1 is 0. So I won't even write that. Well, maybe I will. I'll just go ahead and write it. And then we have to add the first derivative, right? Which is 1 times x minus a, which is 1. Okay, so essentially our first degree polynomial is just x minus 1. All right. All right, so let's go on and find the second degree polynomial. All right, that's the one they actually asked for. So we can take the derivative of the derivative. So I'm going to just use the power rule and apply it to x to the minus 1. So I'm going to end up with minus x to the minus 2. All right. The value of the second derivative at 1 is going to be a minus 1. Okay. So now I can write the second degree Taylor polynomial. It's going to be 0. I'm not going to write that. But f of 1 is 0, so the first term is 0. All right, so now we want f prime at 1, all right, which is 1, and then times x minus a is 1, so we can just write that as x minus 1. Okay, now the next term is going to be the second derivative at a, right, which we just found was minus 1, so I'm just going to make this into a minus. And then so it's going to be minus 1 over 2 factorial. Oops, 1 over 2 factorial. And then x minus 1 quantity squared. All right, so there's our second degree Taylor polynomial. All right, we got to find 3 and 4 too. All right, so it's pretty easy though, right? We can find the third derivative just using the power rule. So we end up with now -1 times the -2 gives you a +2 x to the -3. So the third derivative at 1 is just equal to +2. So the P3, P3, that's right, because it's a third order Taylor polynomial, is going to be, the first the first 3 terms end up being the same thing, right? So you have x minus 1. Maybe I should write this a little bit. Well, maybe I can squeeze it in here. Minus 1 over 2 factorial times x minus 1 squared. And then we're going to have the third order term, which is going to be, it's going to be a plus 2, right? Because that's the third derivative at 1 over 3 factorial x minus 1 cubed. All right, kind of squeezing that in there. All right, now one more. We got to do one more. Let's find the fourth derivative at x. All right, so again, we're just going to use the power rule. We get a -6 x to the -4. So the fourth derivative at 1 is equal to -6. All right, so I'm going to write P4 down here. This is going to be a little bit longer. All right, so the fourth degree Taylor polynomial is, the first 2 terms are the same, right? f of 1 is 0, f prime of 1 is 1. So we have the 1 minus x, and then the next term is also the same. So we get 1 over 2 factorial x minus 1 squared, and then plus 2 over 3 factorial x minus 1 cubed. And now we got to add our fourth order term. So we end up with, let's see, instead of writing plus, because that next coefficient is negative, right? It's a -6. So I'm just going to write minus 6 over 4 factorial x minus 4 to the 4th power. All right, so there's our 4th degree Taylor polynomial. Now, this one I'm going to simplify a little bit just because the simplification is lovely. All right, because it's nice. It's really nice. So let's just simplify this a little bit. I'm going to rewrite this. I'm just going to leave the first term as it is, though. But I can, this is 2 factorial is 2 times 1, which is 2. So I'm just going to write that as 1/2 x minus 1 squared. Now, 3 factorial is 3 times 2 times 1. So 3 times 2 times 1, the 2's will cancel, and I end up with 1/3 x minus 1 cubed. And 4 factorial is 4 times 3 times 2 times 1. And you notice how 3 times 2 times 1 is 6. Okay, so those will cancel. So I end up with a -1/4 x minus 1 to the 4th power. So interesting, right? 1/3, the coefficients are 1 over 1, 1 over 2, 1 over 3, 1 over 4, and they're alternating signs. There's definitely a pattern going on here. And you can see that when you simplify it. So that's why I simplified it in this case. So that's all I have for you in this lecture. So I will see you in class.